Section 7.1, adding and subtracting polynomials. Well, I have some good news. The good news is I think you're going to find the next couple of sections to be quite a bit easier than what we've been doing. We'll see. See if you agree with me here when we're done. All right, in this section, we're going to talk about adding and subtracting polynomials. So we need to know what a polynomial is. It's easiest to define a polynomial by first defining a monomial. Ooh, boy, trouble saying that today. Monomial. Mono, you should recognize, means one. So a monomial is a number or a number times variables whose powers are counting numbers. So let me give you some examples here. Here are some things that are monomials. 7. Monomial is just a number, 7. Or, more commonly, a monomial is a number with a variable and a power, 5x squared. But notice the powers have to be counting numbers. They have to be nice numbers. A monomial could be negative 8x squared y cubed. It might have more than one variable. The number could be a fraction like 3/5 x. Okay? So those are all monomials. Things that are not monomials are things that look like this. 4x to the negative 3. You can't have a power that's a negative number because our powers can only be counting numbers. We can't have powers that are fractions. Those are no good. 5x to the 1/2. We cannot have square roots. We can't have fractions where we have x on bottom. So notice the difference. 3/5 times x, that's a monomial. That's okay because it has an x to the 1, really. 3 over x to the 5th, that's no good. The x is on bottom. Okay, so a polynomial is a sum and or difference of monomials. So polynomials, these are things I know you've seen before. 3x squared minus 5x plus 2. There's a polynomial. Now, this polynomial has a couple important names. This polynomial would be called a trinomial because it has 3 terms, 3 things being added and subtracting. It would also be called quadratic. And quadratic means the biggest power is 2. Okay, so those are a couple kind of terms you're going to see in this section. You're going to see terms like trinomial, binomial, quadratic, cubic. Okay, so let me give you another one. 5x cubed minus 8. This one would be called a binomial because it has 2 terms. And it would also be called cubic. Biggest power is 3. Okay, so you're going to see terms like that, and we will use those terms later on in this course. You'll see them show up. Okay, well, the big thing we're going to do in this section is we're going to add and subtract polynomials. To add, subtract polynomials, we combine like terms. Now, of course, this isn't like Facebook here. You don't get to decide what you like and what you don't like. By like terms, we mean something very specific. Like terms means 2 things. Terms with exactly the same variables, and two, those variables have exactly the same powers. All right, so I'm going to give you a polynomial here. A couple polynomials, and we're going to add them. 8x cubed plus 5x squared plus 6x cubed minus 2x squared plus 8. All right, well, here's what I see. I see I have a couple of x cubes. So I put the 8x cubed together with the 6x cubed. 8 plus 4 is 16. So that's going to be 14, I mean, x cubed. Notice when you add, the powers don't change, only the numbers out front. 8 things plus 6 things is 14 things. It doesn't really matter what the powers are there. Then I see some x squareds. I got a 5x squared and a minus 2x squared. I add those together. That's a 3x squared. And again, the powers don't change. 5 things minus 2 things is 3 things. And then I've got this 8 out here on the end all by itself. It just stays out there by itself. There's nothing to combine it with. There's no other like terms. Let's try subtracting a couple polynomials. 2x cubed plus 5x squared minus 8x plus 9 minus x cubed minus 7x plus 4. All right, when you subtract polynomials, I highly, highly, highly recommend, almost require, that you throw in the extra step. And the extra step here is rewrite it, distributing this minus sign right here through. 2x cubed plus 5x squared minus 8x plus 9. When I distribute that through, I get minus x cubed. Minus and a minus makes a plus 7x, and then a minus 4. I find if students don't distribute that minus sign through, they goof up and they drop one minus sign somewhere. That's why I say I really almost require that you run that minus sign through. Take the extra time. All right, now I find my like terms. I've got a 2x cubed and a minus x cubed. That makes an x cubed. Then I notice I have this 5x squared right here, but I don't have anything else with an x squared in it. So that one just stays by itself, plus 5x squared. Nothing to combine it with. Minus 8x plus 7x, that gives a minus x. And finally my numbers, I got a 9 and a minus 4. That makes 5. All right, the next thing I see happening in this section is you're going to be given polynomial functions. So I might give you the function f of x equals 2x minus 5, and the function g of x is x squared plus 3x minus 2. And I'm going to ask you a few things. I might ask you to evaluate f at 6. And we've done this before. You need to remember what this symbol means. This symbol means take the number 6 and plug it in for all the x values. So I would have 2 times 6 minus 5. I'd work that out. About 7. Or let's say I asked you to find g at negative 2. G at negative 2, that means plug negative 2 in for all the x's. And you might remember before I highly recommended that anytime you plug in a negative number, you put it in parentheses. That will help you get the order of operations correct. And also, if you're using your calculator, when you type in negative 2 squared like this, you need to put parentheses on your calculator too. All right, so negative 2 squared, that's 4 minus 6 minus 2. I get negative 4. The other thing I might ask you to do is I might give you f of x equals, I don't want to use 7, f of x equals negative 3. So if I give you f of x equals negative 3, Basically what I'm doing is I'm giving you the y value. I'm telling you y equals -3. What x number does that come from? So, in reality, what I'm really asking you to do is, instead of writing f of x, write -3. So you would have -3 equals 2x minus 5, and you'd have to solve that equation. Add 5 to both sides. 2x equals 2. Divide. X is 1. Now, I won't do that for the g of x at this point because you don't know how to solve that kind of equation. Again, that kind of function that has an x squared in it, as you can see. So again, we would call that a quadratic equation. But that's what we're building up to in this chapter. We're going to get used to dealing with polynomials and dealing with powers. And then when we get to chapter 8, we will talk about how do you solve polynomials. We don't know how to do that yet, but we'll get to it. All right, the next thing that I might give you, though, is I might ask you to find f plus g at x. Well, that's a fancy way of just asking you to add the polynomials. So I want you to take 2x minus 5 and add x squared plus 3x minus 2. Again, you would combine your like terms. I've got the x squared there, the 2x and the 3x. That makes 5x. Minus 5 and minus 2 makes minus 7. Or I might ask you to find f minus g at x. Now be careful with this one. To subtract, you're going to have 2x minus 5 minus, and again, you really need parentheses here. You need to subtract the entire function. So put that entire function in parentheses. Take the time to distribute that minus sign through. So you end up with 2x minus 5 minus x squared minus 3x plus 2. You're going to take that minus sign and run it through all the pieces there. Combine your like terms, minus x squared, minus x, minus 3. Okay, the last thing I see happening in this section is I ask you to do a little bit of graphing. And I'm going to give you functions like f of x equals 3x squared, and I ask you to graph. Now, the first thing you should notice is the graph should not be a line. And what tells me this graph should not be a line is that power of 2 right there. We know that linear graphs have only a power of 1. So we're definitely sure that when I get all done, my picture should not be a line. So what do? Well, what I would do when I don't know something about a graph, what I do is I start by making a little table. So I would make a little table like so. And I tend to pick a couple of my favorite positive numbers, a couple of my favorite negative numbers, and 0, and I plug those all in and I see what happens. So let's start with the positive numbers. If I plug in 2, I get 3 times 2 squared. That's 3 times 4, that's 12. If I plug in 1, 3 times 1 squared is 3 times 1, that's 3. Plug in 0, 3 times 0 squared is 0. 0 times anything is 0. My negative numbers, I have 3 times negative 1 squared. Negative 1 squared is negative 1 times negative 1, that's 1. 3 times 1 is 3. And when I plug in negative 2, 3 times negative 2 squared, that's 3 times 4, that's 12. So let's see, my scaling here, I might go by 2s. 2, 4, 6, 8, 10, 12. Okay, so I have 2, 12, that's over here. 1, 3, that's right about there. 0, 0. Negative 1, 3. And negative 2, 12. So we definitely don't get a line. We get a picture that looks like this. And there's a name for that. That's called a parabola. So this kind of function, when you have an x squared here, this is called quadratic. And the graph is called a parabola. All right, I want to do one more. G of x is minus 2x cubed. Okay, this is called cubic because the highest power is a 3, x cubed. And again, we'll draw a graph here. Again, I don't know much about it, so I would begin by building a table. And notice I didn't put any scaling on my y-axis yet. I think it's helpful if I build a table first and see what kind of y numbers I'm going to need. And again, I tend to pick a couple favorite positive numbers, a couple favorite negative numbers, and 0. So when I plug 2 in, I have negative 2 times 2 cubed. 2 cubed is 2 times 2 is 4 times 2 is 8. 8 times negative 2 is negative 16. Negative 2 times 1 cubed is negative 2, because 1 cubed is 1 times 1 times 1, that's 1. Negative 2 times 1 is negative 2. 2 times 0 cubed, that's 0, because 0 to any power is 0. 2 times 0 is 0. Oops, negative 2. Good news is negative 2 times 0 is still 0. Now, negative 2 times negative 1 cubed, that's negative 2 times negative 1. Because negative 1 times negative 1 times negative 1, when you have 3 negatives, you get a negative. That's going to be 2. And similarly, negative 2 times negative 2 cubed. Negative 2 cubed is negative 8. So that's negative 2 times negative 8, which is 16. All right, so I think I'm going to go 4, 8, 12, 16, because I see I need to get all the way up to 16. Negative 4, negative 8, negative 12, negative 16. All right, so I have 2, negative 16. 1, negative 2. That's right about there. 0, 0. Negative 1, 2. And negative 2, positive 16. All right, so we get an interesting picture. Definitely not a line again. We knew it wasn't going to be a line because I had an x cubed. We get a picture that looks like that. While the one up above had a special name called the parabola, as far as I know, this one doesn't have a special name. It's just the graph of a cubic function. All right, so that gives you an idea of everything you should see in section 7.1. I hope you'll agree with me that section 7.1 is easier than those word problems we were doing at the end of chapter 6. We'll move on to 7.2, and I think you'll agree that 7.2 is better than what we did in chapter 6 also.